Hello and welcome to the eOrganic webinar on setting up a grazing system on your organic dairy farm. My name is Deb Haliba and I work at the University of Vermont Extension as eOrganic's Dairy Team Coordinator. eOrganic is an online community of more than 500 ag service providers and farmers who are providing science, experience, and regulation-based certified organic information on the web. Together we publish articles, videos, and other content at eextension.org. This webinar is part of an ongoing series focused on the access to pasture rule. You can find recordings of our past webinars, the recording of today's session, including a PDF of the slideshow that you'll see today, and view our other content on our website at www.eextension.org/organic_production. Okay, now I would like to introduce our speakers today. Sarah Flack is a national consultant specializing in grass-based livestock farming and organic certification. She grew up on a farm in northern Vermont where she and her family grazed sheep, dairy and beef cattle, pigs, poultry, and goats. Sarah received her Bachelor of Science degree in Environmental Agriculture and Biology and her Master of Science degree in Plant and Soil Science from the University of Vermont. She has more than 25 years of experience working with livestock farmers across the country interested in management-intensive grazing and/or certified organic farming. Cindy Daley is a professor in the College of Agriculture at the California State University at Chico. She received her Bachelor of Science degree in Animal Science at the University of Illinois and her PhD in Animal Science at the University of California at Davis. Cindy is the faculty supervisor and manager of the Organic Dairy Teaching and Applied Research Unit at CSU Chico, where in 2007 she spearheaded the effort to transition their 80-cow dairy to a certified organic operation. Sarah and Cindy, thank you very much for joining us today.
Thanks, Deb.
So this is Sarah speaking. I'm going to get things started here. What we're going to do today is Cindy and I are going to take turns presenting different parts of the webinar. And just to give you an overview of what we're going to go through today, we're going to go through first what causes some pastures to be poor quality and others to be high quality, and then some of the key points of what management-intensive grazing is and how you do it, and how to choose a grazing system for your farm. We'll talk about overgrazing damage, how it happens, and how to avoid it. We will talk about variable recovery periods, how to deal with that, and then how to fill in some of those gaps in your grazing season's forage supply in the pastures. We'll then go into some detail on paddock size calculations to figure out how big the paddock needs to be to feed the animals, and then how many total acres you need at the different times of the grazing season. We'll go through some example farms, which will also give us the opportunity to talk a little bit about some of the electric fence technology, ways to construct lanes, provide shade, how to factor in irrigation systems, and provide water in the pastures. And then we'll briefly go through some of the pasture pitfalls and disasters and talk about how to avoid those, and hopefully leave you with some additional resources of where you can go and learn some additional information. This is a fairly short format of the webinar today. We've only got 45 minutes, and so we're not going to get into a great deal of depth in any one of these topics. We're going to try to cover each of them with enough information so that you can have the basic idea of it, and then hopefully send you some ideas on where you can go get more information. So let's get started with talking about poor quality pastures, and then we can get that over with and just look at slides of nice quality pastures for the rest of the webinar. So poor quality pastures, commonly we would like to blame the selection of plant varieties that are planted in there, or we would like to blame the soil fertility of the pasture. But in my experience, it's almost always caused by poor grazing management or a poorly designed or managed grazing system. And usually, even if you do correct the soil fertility problems or plant a new variety of pasture plants out there, if the overgrazing damage being caused by an incorrectly managed rotation or grazing system isn't corrected, even the best soil fertility and the best plant varieties will eventually revert to a poor quality pasture. And so the example that you're seeing in this slide here is, in this case, it's actually a beef herd, and it's being grazed on a fairly large pasture. There's about 39 acres and just about a dozen cattle in there, so not a huge number of cattle. But they're in there continuously throughout the whole grazing season for several grazing seasons in a row. And what's happened is that they've been repeatedly returning to the plants that are the most palatable, the most delicious to cows, and grazing them over and over again, not giving those plants a chance to rest and regrow. And over time, those plants have been just staying short and are really very stunted now. And then the other thing going on is there's now soil erosion starting to happen in parts of the steeper pastures where the plant roots can't even hold the soil in place anymore. So this is one example of how overgrazing damage can cause the pasture quality to decline. So this is another example of continuous grazing causing overgrazing damage, but it looks very different than the previous slide. In the previous slide, it's kind of what we classically think that overgrazing damage is, when things are grazed down very short and they seem to just stay short all the time. This is an example of a pasture which probably has equally as little really good quality feed in it, but from where I'm standing, where I took this photograph on the side of the road, it looks like there's a lot more growing out there. But if you go through this pasture and actually walk through it, what you'll see is that there are a whole lot of very short areas where the cows have been grazing over and over again and keeping things very short. And then there are areas where there's either weeds or tall, over-mature grasses that the cows just don't want to graze anymore. And so there's still not a whole lot of good feed in here. It just looks very different. So these are two different examples of how overgrazing damage and continuous grazing can cause pasture quality to decline. So what causes good quality pastures? So now let's look at a slide of a dairy quality pasture. And this is a pasture which is just the right height to allow the pasture plants enough time to regrow and photosynthesize, regrow a strong root system, store energy in the roots so that they're prepared to use those root reserves to regrow the plants after they're grazed off the next time. So it's ideal for the pasture plants. In this case, these are cool season perennial plants in a New York State farm. And the other thing about the ideal rested plant is that that height, which is in this case like 8 to 10 inches tall, is exactly the right height to allow the dairy cows to maximize dry matter intake of very digestible, high protein, high quality forages. And there was a previous webinar done by Karen Hoffman a couple of weeks ago called Maximizing Dry Matter Intake from Pasture, and that is now posted and available on the eOrganic website. And that would be a great one for you to watch if you want to learn a little bit more about the dry matter intake from the cow's perspective. A lot of this webinar will be from the plant's perspective, and Karen's webinar was from the cow's perspective of how to just get as much of this high-quality pasture into the cows as possible. So the concepts that we're going to be talking about today are not new. This is a quote from Robert Elliott in 1898. He said that the management of the pasture is even of more importance than the selection of the seed and the preparation of the land. So it's just a reminder that the management of the pasture is really the most important thing, and it's the thing to be addressed first. And then second, we'll be looking at soil fertility and what varieties you should be planting. Because if you fix the soil fertility and the seed variety that you plant, but you don't change the management, it's still going to be a weedy mess or an unproductive pasture. So a lot of the pasture that we'll be talking about in the webinar today are perennial pastures. So those are pastures that you may plant, or it may just be what's naturally growing there. And the plan with those sorts of pastures is not to have to reseed and replant them frequently. And so we'll be talking about management systems that should improve the quality and quantity of feed in these perennial pastures over time, just by changing the timing of your rotation and allowing the plants more rest between grazings. We will also be talking some about using annual species for grazing to fill in gaps in forage supply or to extend the grazing season. So I just want to talk a little bit more from the plant's perspective of what they need to really be happy and growing vigorously. This is a plant growth curve. You can see here it says plant mass. So this is the total amount of plant material that's grown up in the pasture. Could be plant height, if that makes more sense to you. And then time here in days that the plant has been regrowing. And so this curve is an example of a typical perennial pasture plant, which right here is very short. It's just been grazed off by the cows. And right after it's been grazed off, assuming that the cows are then taken out of that pasture so that those plants can start to regrow, the plants will begin by growing quite slowly because at this beginning stage they need to regrow their leaves so that they can start to photosynthesize. But because they don't have any or many photosynthetically active green leaves at this point, they have to use energy from their roots and move it up and start to regrow leaves. So they'll grow quite slowly at this stage, and then will start to grow more rapidly at this stage when they've got more green leaves starting to make photosynthate and energy. The temptation at this point for both the cows and us as farmers is to let the cows go back in there and graze it off again, because it looks like there's feed available in there. The cows would love to go eat it. It's very digestible, juicy leaves. But for the plants, this is a very damaging time to graze the plants because they haven't had enough time to actually regrow enough leaves, which occurs up here, so that there's photosynthesis going on and enough energy being transported down into the roots. And it's really not until this stage here, this height of plants, that you want to start letting the cows back in there to graze again. Now this exact height right here is going to vary depending on the plant species that you have in your pastures. For the cool season perennial grasses in the northern tier of the U.S., it's probably going to be in the range of 8 to 10 inches. There may be some systems that are a little bit shorter than that or a little bit taller than that. As you get into more of the southern grass and legume species, you may have a taller pre-grazing height than that. So it's something you need to figure out for your own farm based on the forages that are growing there. And those could be some of the questions that we can answer as we go along in the chat box or at the end of the webinar. You can type your questions into the side there. So here is a really nice, high-quality, dairy quality pasture, and again, I just want to remind you that what's good for the cows is good for the plants. This pasture has been allowed to regrow to exactly the right height, so the plants are fully recovered and ready to be grazed down, and they'll grow back again vigorously. And you can see that this cow is wrapping her tongue around a tuft of red clover and some grass species. It's going to be really easy for her to bite that off and fill up her rumen and be able to really maximize dry matter intake from this. So I'm going to turn things over to Cindy here.
Great. Hey, thanks, Sarah. There are a number of different grazing systems in practice around the country today. Each has a very profound impact on grazing behavior, as Sarah's been discussing. And it's this grazing behavior that will impact species composition in your paddocks. So clearly, your pastures will reflect your management, for better or for worse. Let's go on to the next slide. There we go. Just taking a look at this diagram, it depicts 3 different types of grazing programs. The diagram on the top left is an example of a continuous grazing system or a set stocking rate, which is a very common grazing method because it's low cost and it's easy. It places animals in these large paddocks without a rotation or a rest period and can lead to this type of selective overgrazing, and that the cows tend to focus their attentions on those plants that are the highest palatability, and it leaves the undesirable plants without any competition at all. The diagram on the top right shows a rotational type system. Now that subdivides those paddocks into a slow rotation, could be 5-10 days. Now that is an improvement over the set stock because there is some rest associated with the slow rotation, but it really doesn't eliminate that selective overgrazing problem that we have. The bottom half of this slide goes into managed intensive grazing. Now that's where these paddocks are further subdivided into intensive heavy stock densities for very short grazing durations. And these grazing durations could be 12 hours or less, with very long rest periods between the grazing cycles. So when managed correctly, each paddock will be at a different stage of forage regrowth, which optimizes the forage quality at the time of grazing. And it really helps to eliminate the selectivity for the more palatable type forages. What grazing system you pick really depends on a number of types of factors. Questions you might want to ask yourself include, well, how much grazing do you actually plan to do? In other words, what's your target DMI? You will then need to establish how many acres that you have available for grazing. So the target DMI in your available acreage will dictate just how much supplemental feed you need to have on hand. You'll also need to consider water availability and whether or not you can get water to all those pasture locations, and can you do it economically. And how about irrigation? Out here in California we do a lot of irrigating. Do you need to develop irrigation in order to achieve that type of targeted pasture DMI? And of course there's some seasonal considerations and labor availability. The more intensive grazing programs will demand more time. Some of the reasons why we like MIG, or managed intensive grazing, is because we're able to carry more cows per acre, and in the process you're actually improving your feed quality. It does eliminate trailing for the most part, and the opportunity for soil erosion that comes with trailing. Managed intensive grazing also optimizes the plant regrowth time and therefore builds soil profile, because these roots are also regrowing at the same time and they're pulsing through the soil profile with each grazing cycle. And because cattle are distributed more evenly throughout the pastures, we're getting more even distribution of nutrients throughout the entire paddock, and these long rest periods create an opportunity to break internal parasite cycles, which is also a big benefit. This diagram really shows the impacts of MIG on forage quality. This is the results of a 3-year study where forage samples were collected from 34 different MIG dairies in the New England area, and then contrasted back to hay and silage samples for key quality assessments like total digestible nutrients, NDF, and ADF. Managed appropriately, these pastures were comparable in quality to some of these harvested type feeds, and without the equipment, the labor costs that were associated with growing, harvesting, storing, and feeding a TMR. In this case, the cows did the harvesting. Sarah?
So I'm just going to go over a couple of slides on overgrazing damage, and then Cindy will take over again. We've already talked about overgrazing damage, and I just really wanted to put a couple of extra slides in here because I find that the more years I do grazing consulting, the more I find that overgrazing damage really is the #1 reason that grazing systems over time don't work well for farmers. And so just to review, overgrazing damage occurs any time when livestock graze a plant while it's still growing from its carbohydrate reserves in the roots, instead of growing from active photosynthesis from the leaves. And overgrazing commonly occurs when animals stay in a paddock for too long or are returned to a paddock too soon so that the plants aren't getting enough rest to fully recover. So here are some common situations when overgrazing damage happens. One particularly for northern tier farms, which is in the fall when we think that the plants in our pastures really aren't growing anymore, but it actually turns out that some of them are, is taking down all of those interior fences and in that fall season to let the livestock just clean up the pastures can really do some serious overgrazing damage to our most productive, rapidly growing pasture plants. And having a simple rotational system where you just have 6 or 7 paddocks, each one is grazed for just 1 or 2 days, so you end up with a fixed recovery period instead of a variable recovery period, means that when the plants are growing more slowly, you're going to be doing overgrazing damage to them because they won't be fully recovered. And then anytime that animals are being left in a pasture for more than about 3 days in a row, they'll start overgrazing because they're going to regraze the plants that are just starting to regrow. And this exact number of days is going to vary depending on where you are in the country, what plants they are, and what the climate is. But it's usually in the range of 3 to 5 days in either an area with natural precipitation or irrigation to get the plants to grow relatively quickly. And then, of course, returning the animals to the pasture before all of the plants are regrown. Or another one is not adding additional acres into the summer grazing rotation as plant growth rates slow down. And the plant growth rate will slow down in different parts of the country at different times of the growing season. But that's the time of the year where you either need to limit the size of the paddock so that your rotation's not too fast, or add more acres into your rotation. And Cindy, you can take over here again.
Great. Hey, thanks, Sarah. Variable recovery periods. When you graze cattle over a long period or an extended period of the year, you have to deal with these extended recovery type periods because they do change and fluctuate throughout the year. These rest periods really need to be based on your observations of the paddocks. These regrowth rates do change. In spring, regrowth rates are very fast as compared to the fall. So if you do try to use the same recovery period for your fall feed as you do for spring, you're going to have a real negative impact on your pasture composition, your forage quality and your pasture composition. So how do you deal with some of these variabilities? In spring, cool season feed really grows so fast that it can be in excess to your stocking rates. We have this kind of a situation on our farm. In other words, you just have more feed than you have cows. So setting aside a couple of those paddocks for hay or round bale production rather than allowing the pastures to go overgrow and become excessively rank is going to be better all the way around. Forage is allowed to go to maturity, of course, drop in overall quality. So you need to take it off and store as much of that feed as you need in order to resynchronize all those paddocks to get it back into your grazing system. That'll optimize forage quality and forage availability. And you'll be going into those paddocks at the appropriate height and maintain good feed quality at the same time. On the other end of things, you also will have to deal with forage gaps. Where we're at, out here in the west, we have a summer slump that's due to summer heat. So in that situation, we really need to consider forage sequencing. For example, just design a system to grow some additional warm season annuals to fill in those forage gaps. That may include some overseeding into cool season paddocks like in May and just to achieve some warm season growth in July and August. Or you can set aside some additional acreage to plant some summer annuals specifically for grazing purposes. The amount that you'll need really depends upon your expected DMI throughout the season. Other methods to fill gaps include extending the cool season with some plant species that tend to be a little more adapted to that warm environment. And that would, in essence, stretch the cool season growth curve well into that summer slump. So I think, Sarah, I'm back to you with paddock size and acreage calculations.
Yep. All right. Great. So in this next section, I'm going to go through how to do paddock size calculations to figure out how many acres per day you need to provide enough dry matter for a group of animals. And then we'll go on to calculate how many acres you need at the different times of the grazing season, depending on how long the regrowth required for the paddocks to grow back is. So this is the information that you need in order to figure all of this out. First of all, you need to know how much dry matter is available per acre in the pasture. And we'll talk about a couple of different ways to figure that out. And then second, you need to know how much dry matter does the grazing group need per day. And so we're going to be doing these calculations per grazing group. So it might be your milking group. You could do a calculation separately for your heifers and for your dry cows if you're grazing each of those in separate groups. You would do the paddock size calculation separately for each of those. If you run them all in one grazing mob, then you would just do one paddock size calculation for the whole group. Once we know how much is available and how much is required, we can then calculate by dividing the required amount of dry matter per 24 hours by the available amount per acre, and that gives us the number of acres needed. So this is an example of a correctly sized paddock. This is a farm in Massachusetts, and you can see that they had previously grazed this area where the cows are kind of facing right now, and there's now a polywire fence separating them so that they can't go back and back graze where they've grazed the previous day. There's also a fence behind them separating them from the pasture in the back where they'll go and graze after their next milking. And so this is a 12-hour paddock that's been calculated to feed this group of cows. I think there were just over 100 cows in this group. And so you can see there's a good stock density in there. Cindy was talking about how the manure gets distributed, and you also get good hoof impact. So there's a lot of benefits from having a correctly sized paddock other than just making sure that you're providing enough forage for the grazing group. So here's an example. This is actually more of a western farm, I think. This is a post-grazing height where the cows have grazed previously, and this is a nicely grazed down finished paddock, and you can see it's being separated from the next paddock that they're about to go into, which is over here, by a single strand of polywire on these nice little portable pigtail posts. You can just see one behind the high tensile fence post there. So that's an example of a pre-grazing height and a post-grazing height. And in this case, if we went in here and used one of the direct measurement techniques that we're going to talk about next, there would probably be about 1,200 pounds of dry matter available per acre in there. If it's a very dense or taller pasture, then it might be even more than that. So how do we figure out how much dry matter is available per acre? One way is to do direct measurement of the pasture. The simplest low-tech way to do this is a grazing stick. I'll show you a slide of that next. And then some of the other ways would be a rising plate meter, which can be purchased, and those are either digital or manual ones. Clipping, which is where you actually go out and clip a measured area in the paddock. You dry that material, and then you weigh it and use a formula to multiply that out to tell you how many pounds of dry matter is available per acre. And then an electronic capacitance meter, that's the ECM there. That's another digital way of measuring the amount of dry matter available per acre. The rising plate and the electronic capacitance meter will cost you a little bit more money, but if you like digital things, that would be a way to do it. Otherwise, the grazing stick I'll show you next is definitely the cheapest way to do it. You can also get the information from a table that gives you an estimate of the amount of dry matter per acre, and I'll show you one of those also. So this is a grazing stick. This is me demonstrating how to use a grazing stick to measure the amount of dry matter available to graze. One of the nice things about these grazing sticks is it tells you the grazable amount. It doesn't tell you the pre-grazing amount and the post-grazing amount, and then you have to do a little math. It actually directly gives you a measurement of available grazable dry matter per acre. I won't go into detail about how to use this or how to do this here, but I will say that there is now posted on the eOrganic website a short little instructional video that we put together that shows you how to use one of these sticks, and Deb Haliba also put an article on there that gives you a list of locations in different parts of the country where you can get these grazing sticks. Ideally, you want to learn how to use those like at a pasture walk or a pasture workshop or something like that so that you can practice using it, because the most common mistake with any of these techniques is that we can get overly optimistic and overestimate the amount of dry matter that's actually out there. So then this is another way, if you're trying to just figure this out and it's the non-grazing season and there's nothing to go out there and measure. This is a worksheet which is in one of the National Organic Program articles on the National Organic Program's website. And this table is found in the article titled Pasture Worksheet for Rotational Stocking Systems. And there's two tables in this worksheet. One gives you a number of pounds of dry matter per inch, so your dry matter estimate is based on the height and density of the pasture. And this table gives you a number based on the hay yield equivalent. So if you convert a hay field to pasture, and for example, if that hay field would be expected to yield about 3 tons to the acre per season, then you would expect to be able to have the cows harvest about 1,200 pounds per acre from that hay field each time they rotated through it, as long as it was fully regrown and recovered before each grazing happens. So let's go through and figure out how to actually do this now. Once you've figured out how much is available, next we've got to figure out how much they need. And so for your grazing group, if this group of animals is getting 100% of their dry matter intake from pasture, you're planning on feeding them nothing except pasture, then you just take the number of animals in the group, the total number of animals in that grazing group, and multiply it by each of those animals' daily dry matter demand, and that will give you the total pounds required. And for those of you who didn't attend one of the previous webinars we did, I taught a webinar a month or two ago called How to Calculate Dry Matter Intake from Pasture, and we go through in quite a bit more detail how to figure out what the dry matter intake and dry matter demand of groups of animals are. And you'll also get some additional information on that from Karen Hoffman's webinar. Basically, the dry matter demand is the total amount of dry matter that the animals need to eat per day. So that'll be fairly common for heifers and dry cows, that you're providing all of their dry matter from pasture. And occasionally you'll see that with a dairy group if you've got very high quality pastures and the correct well-selected grass genetics in your herd. But usually it's just going to be the dry cows and the heifers, and it'll be more typical for the dairy herd to be getting some feed in the barn or feedlot in the form of hay or silage or grain or all of the above. And so in those groups of animals, you're going to want to take their dry matter demand, the total amount that they need. From that, you're going to subtract the dry matter that they're being fed in the barn or feedlot. And then that difference will be the amount of dry matter that you plan to provide to that group from pasture. So then this is the number we'll use per animal. We'll multiply the number of animals in the group times the total amount of dry matter you want to get from pasture per animal, and that will give you the total pounds required. So obviously if you're providing 100% of the dry matter from pasture, you're going to need larger paddocks to provide more dry matter to the group. So now, how big should the paddock be? The way you figure this out is you take the dry matter demand required for the whole group for 24 hours, and you divide that by the available dry matter per acre, and you'll get a number which will be number of acres needed per day for that grazing group. So let's just take a look at one example here. So this is an example where there's 80 cows, and the farmer has decided that they want to try to provide 32 pounds of dry matter per cow in this group. And so the first thing we do is we take the 80 cows, we multiply times the 32 pounds per cow, and we find out that the whole group needs 2,560 pounds of dry matter per day from the pasture. And the farmer has gone out and measured the amount of dry matter per acre, and at the time of the measurement came up with 1,200 pounds of dry matter available per acre. So now we've got enough information to calculate the paddock size. So it's the required amount divided by the available amount, and in this case we get 2.1 acres per day. And this would change if they were feeding more in the barn and they didn't need as much dry matter from the pasture, or if it was a different time of the year and this number of pounds of dry matter available per acre was lower or higher. But for this measurement right here, it's 2.1 acres per day. So if we just want to then quickly figure out how many acres total would be needed, depending on how long these paddocks need to regrow, we could look at a high-speed regrowth time of the growing season when things are growing quite rapidly. It's not too hot and there's good soil moisture. Things are growing back in just 21 days. We would take the 2.1 acres per day, multiply it times 21 days, and find out that we would need 44 acres to feed this group of cows this much dry matter at that time of the year. And then if we wanted to look at a time of the year when the pastures are growing more slowly, the time of the year when, in this example, 36 days is how long it takes for them to regrow, we would take the 2.1 acres per day, multiply it times 36 days, and it would be 76 acres in order to provide the same amount of dry matter per cow. Okay, great. Cindy, you can take over with the first example farm then.
Okay, good. We thought it would be helpful to then take what Sarah's been discussing in the calculations and actually apply it to a farm scenario. So we're going to apply those calculations to the university's organic dairy herd. And we basically have an 80-cow Jersey organic herd. We try to graze on about 40 acres of irrigated pasture that's been dedicated specifically to the lactating cows. In spring, we target about 80% DMI. In the spring, when we have cool season growth, it's very lush. And we have to back that down to 40% or less during the warm season, during the summer slump and into the fall. Overall, we'd like to target about a 180-day grazing period. And the way in which we're calculating our dry matter demand is based on that 4% figure that we pulled from the NRCS tables. So our cows average right around 1,000 pounds body weight. Multiplied by that 4% would give us about a 40-pound dry matter demand per cow per day. So in the spring, when we've got an 80% pasture DMI target, that would amount to about 32 pounds of pasture DMI per cow per day. When you multiply that through by our 80 cows, That's 2,560 pounds of dry matter that we need to get from our pasture each day. The next step, according to Sarah's method, is to decide what our available dry matter is. And we're probably a little high, perhaps. We use a capacitance probe for some really fast and easy numbers. We do a pre-grazing and a post-grazing height in our paddocks as we come in and out. And this is what we approximate our dry matter availability at per paddock, at about 2,200 pounds. So to establish just how many acres we need on a daily basis, we would take that demand, the 2,560, and we would divide it by what we think we have in our paddock available, would be the 2,200. And we would get 1.16 acres per day that we need to allocate to our cow herd. And since we're on managed intensive grazing, we would divide that in half, and we would give the cows half of that for 12 hours, and then at the following milking, open it up, and they'd get the other half in the following time allocation, the next 12 hours. So overall, what kind of a rest period would that give us? This is our pastures that have been designated to for the organic dairy herd. Each of these paddocks is approximately 5 acres or so. And what we need to do is establish what our rest periods will be. And if we take our 40 acres that have been allocated and divide that by our need, which is 1.16 acres per day, we end up with about a 34.5-day rest period between grazings. Now in the spring, that may be a little bit longer than we necessarily need. And so what we have been doing is we've been taking off 1 or 2 paddocks and taking that off as round bales, and we'll store that feed for our young stock or dry cows, or depending upon the feed quality. If it's really good quality, we might even use that for our milk cows. It just kind of depends. I guess the other option, of course, would be to move more cows on top, but we don't really have that kind of flexibility to be able to add milk cows. And that type of thing. So what happens then when we get to the fall? Well, in the fall, we have a much slower regrowth rate, and our warm season grasses just don't have the tonnage that our spring feed has. So we've calculated our available dry matter at about 1,200 pounds per acre during that period of time. So if we take our dry matter demand, if we're going to maintain that 80% DMI from pasture, 2,560, and divide it by what's available at that time of year, we need 2.1 acres per day. And that would calculate into a 19-day rest. And with everything that we know about rest periods in the fall, that would be devastating to our pastures. We would definitely change species composition if we were to only implement a 19-day rest. So the solution, of course, is to do a couple of things. We could add acreage, or what we have to do, because we don't have that kind of acreage available, is that we would have to change our expectation in terms of dry matter DMI. So our availability is still at 1,200. Now our dry matter demand drops to 1,280. So for the entire herd. That means that we're going to be making up the rest of this DMI with supplemental feeds, silage, hay, that type of thing. So if we take our demand and we divide it by the available dry matter that we have in our paddocks that time of year, we end up with a 1.1 acre per day requirement. And that would calculate out to be about a 36-day rest period. But again, we would have to take a look at those paddocks before we would, be okay with that 36-day rest period. If our paddocks didn't appear to be responding, in other words, we needed longer rest periods, we would have to do some further adjusting. So it is kind of a dynamic system. There's nothing really easy about it. You do have to be on it. So in summary, what our grazing season looks like is basically over that 180 days. We've got 90 days of spring grazing at 80% DMI. We have about 90 days of summer-fall grazing at 40% DMI, and then throughout the season, we have about 180 days that we were able to get approximately 60% DMI from our pasture over that entire period. So with that, I'll go ahead and I'll turn it over to Sarah, and she can talk about some other examples of other dairies around the country.
So that last example, I think, is a really great one because it goes through some of the complexities of how to change either the paddock size or the number of acres to make sure that your recovery periods are varied to meet the plant's needs. And if you want a little bit more information on calculating the percent dry matter intake from pasture to make sure that you are meeting the organic standards, there was a previous webinar on that topic. So I'm going to go through two other example farms real quickly here and then get into some more detailed slides on fence and lanes and water systems. So this next slide is a mixed breed seasonal dairy. They're actually now drying their cows off for a couple of months during the non-grazing season. But during the grazing season, they are providing 87% dry matter intake from pasture averaged over the whole grazing season. So this is a high pasture dry matter intake farm. They have 30 cows on this farm, and their usual paddock size in their perennial pastures is 3/4 of an acre, 0.75 acres. And in addition to these perennial pastures, they also supplement with some annual forages to fill in their summer slump when it does get a little bit hotter and drier and the perennial pasture growth rate slows down. And what they've been using on their farm, well, let's first take a look at their perennial pasture system. This is an area where these are the perennial pastures. They've set up permanent high tensile fences, in this case 2-strand fences, around the perimeters. You can see that they've got some of the the corner braces down here at the lane that runs down the side of the woods. There's a lane that runs down here that they haven't had to do a lot of improvement to because it's some of the high dry land on the farm. I'll show you some other areas where lane improvements do need to get made. And then you can see that there's a pipe running across the lane here, and it actually runs down the side of the lane here, and that provides water to these portable tubs which can be moved as the cows are rotated through. So we've got these large rectangular pastures on either side of the lane, which are then subdivided with polywire. You can see there's one strand of polywire here and a small plastic step-in portable post here. And also these are spring gates that are like slinkies, and so they can be shut. Right now the gate to the paddock is shut, but they can get stretched right all the way across the lane to stop the cows and direct them into the paddock that they need to go into. It's just another view of the pastures on that farm, the perennial pastures. So this is the annual crop that they were grazing to be able to extend their grazing season through that dry summer period and not stress out their perennial pastures by overgrazing them. This is a crop of millet that they planted, and this is Brent and Regina Beidler own this farm. And you can see that there is a piece of polywire here. The cows have just barely been turned into here, and the polywire is just keeping them confined to a small strip of this millet. And this is just, about the next 15 minutes. They've grazed this down very rapidly, and within the next hour or two, they had the area grazed down quite short, and then they would be returned to the perennial pasture. It's not meeting all of their dry matter intake requirements. It's just taking some of the pressure off of the perennial pastures during the mid-season. And again, you can see that there's the piece of polywire here, which is preventing them from going forward into the rest of the millet that's being saved for the next few days. So going on to another example farm, this is a farm that has 75 Holsteins. They use a variable paddock size because they have variable pasture quality. They have some very high quality hay meadows that they converted to pasture, and these were areas they previously grew corn crops in. And then they have some other land on the other side of the stream and the other side of the highway, which tend to be more variable in quality, includes rocks and trees and swamps, and they're not square and flat. And in order to get to those, they had to construct a stream crossing and a road underpass. They use high tensile perimeter fences on this farm, like the slide in the previous farm was doing, with the subdivisions done with polywire. And I also want to mention that they got payment assistance for the lanes, the stream crossing, the piped water system, and the fence through an NRCS program. The Natural Resources Conservation Service has several programs to help farmers pay for grazing implementation practices. And if I'm going through any of the math or any of this too fast, just remember that you can type in your questions in the little chat box on the sidebar there. So this is just a slide of some of their high-quality pastures in the areas they converted from meadow. You can see the Holsteins are in one paddock, and then using polywire and small portable posts, they've subdivided this into a series of paddocks, and they'll be rotated through these paddocks. I'm guessing that in this slide they're probably rotating through these paddocks as either a day grazing or night grazing, and then crossing the stream to some of the other paddocks which are here for the other part of the day so that they're able to balance out the forage quality. So they had to build a rather steep lane down to the stream here. They did a really good job with some erosion control in that lane so that the cattle can comfortably walk down the lane, and they haven't had any erosion or gullying forming in there. That was with help of NRCS. And then the lane runs along the bottom of these paddocks. You can see that they're much more variable in quality than the ones on the other side. And they also have piped water running along the side of these lanes. And then here they go through the highway underpass, and this is an improved lane where they've actually put down a road building filter fabric. I'll show you a slide of it in a little while, with the gravel over the top of it so that they don't have to rebuild the lane as often as the cows push the gravel down into the mud and clay underneath. This is the farmer, Guy Schwanier, and he's just demonstrating his pile of grazing accessories that he uses for rotating his cows through the paddocks every day. He's got the polywire actually rolled up on this is actually an electric cord reel. It's a cheaper way to do it than a polywire reel. He's got the polywire on there. He's got this little pile of portable pigtail-style electric fence posts. Each one has a little step on the bottom to shove it into the ground. The insulator is built right into the top of it. It's a vinyl insulator on the top. And then this is the portable water tub that he's using. The float valve is right inside it. And then he's just going to connect this hose up to a quick connect on the black plastic pipe that runs along the side of his lanes so that he can have water in each paddock for the cows and not have them wandering back to the barn, because on his farm it's quite a ways to get the cows back to the barn for a drink. This is just another shot of his lane, and you can see here this is a paddock that they've already grazed, and it was then clipped, and there's a piece of polywire keeping them out of the next piece that's ready to be grazed. He's also using those same spring gates here so that he can stretch the gate either across the lane or across the gate opening. And again, that's a 2-strand high tensile fence for the perimeter fence, which is really good at getting the high voltage electricity out to all of the pasture areas and good at keeping the cows in. So I'm just going to quickly go through some more of the grazing accessories here. Starting with water tubs. The ideal system is to have water in each paddock so that then you can lock the cows right in the paddock, have them in there drinking their water, grazing. And in order to do that, you'll need to correctly size your water tub and make sure that you have an adequate flow rate of water. And so in this case, this is a fairly small water tub, but this is a float valve that allows in a high rate of water flow. And it's hooked up to a 1 or 1.5 inch water line that runs along the sides of the lanes. And these water tubs are also flexible plastic, which for these smaller tubs actually makes it harder for the animals to knock them over, because when they start butting them with their heads, the water just splashes on them instead of tipping right over sideways. And then this is switching. Here we go. Okay, switching to the next slide. So the next slide shows where the water tub then with the garden hose is snapping into a quick connect on the black plastic pipe, and this quick connect also has a shut-off on it so you can shut the water right off. So this sort of piped water system out to all of the paddocks is ideal, but not always practical or possible, and it may also be something that gets added to a grazing system several years after you set up the fencing in the paddocks. And so using some sort of a tank to transport water out to either the paddock or a lane or a watering area near the paddock is another option. In this case, the farmer was no longer using his liquid manure tank or system, and so has washed out the liquid manure tanker and was using it to then put water into these water tubs just using a float valve and gravity so that the cows didn't have to walk all the way back to either a stationary waterer or to the barn to drink. So I could go into a whole lot more detail on that, but I wanted to move along here. We've got, also we wanted to talk about irrigation systems. I'm not going to specifically talk about types of irrigation systems here. I just want to mention it because the type of irrigation system that you have, particularly the amount of area that you need to irrigate each time if you have either a flood system or an overhead system, will have an impact on how you do your grazing rotations, because you'll need to time your rotations to the irrigation system that you have so that you're not shorting any of the pastures on needed water, and you're also not grazing them when the soil conditions are too saturated and causing damage to the plants that way. Shade is another thing to consider. A common question that I'll answer now, no, shade is not required by the organic standards, but common sense means that in climates where it's appropriate to provide shade, some or all of the time it should be provided. And with shade, it may be, if in your climate, you may need to have shade in all of your paddocks, or you may want to have just designated shade paddocks that you use when it's very hot, or particularly if it's very hot and humid. But you may find that you actually don't want to have shade available if there are times in your grazing season when it's really not hot or hot and humid, because the animals will still tend to congregate in the shade and just create a whole lot of mess when they really don't need it. Just want to mention that if you're finding your livestock are not respecting your fences, you should check and make sure your energizer is correctly installed. I find one of the most common causes of the animals just not respecting the fences and getting out is the grounding system is not large enough. And the quick way to test that is to make sure that you have no voltage on your ground and lots of voltage on your fence. And you really should have no voltage on your grounding system even when your fence is quite badly shorted out. And also want to mention lightning protection for your energizer. You need lightning protection where you plug it in on a surge suppressor, but you could also install some lightning protection to prevent surges of electricity from coming in on the fence line themselves back to the energizer. This is a diverter up here and then a choke down here, two of the many types of lightning protection that are available. And as you're setting up your system, the permanent fences can be really much easier to manage if you put in switches so that you can turn off whole sections of the fence to either increase the voltage to an area where you're trying to do something like train the heifers or calves with a very high voltage fence. Or the switches can also be very helpful with troubleshooting why you have low voltage in some areas of your fence and finding shorts and things like that. This is just a close-up of the road building filter fabric that a lot of farmers will use in wet areas, particularly muddy clay soils, underneath the gravel, and it can save a lot of money in the long run with gravel in those areas because the cows can't push the gravel down into the soil. And oh, I went through two there, but the other one was just a dry lane where the lane improvements weren't so necessary. So I'll just quickly go over some pasture pitfalls to avoid. One of these is poor animal performance from feeding too much protein in a high-protein grain or haylage. I'm sure Karen Hoffman spoke about this in her webinar a couple of weeks ago, but this is a big problem that results in cows not breeding back, high levels of nitrogen in the milk and in the blood for MUNs and BUNs can be tested for, and you can also have laminitis and cows losing weight from this. Poor animal performance due to low dry matter intake because the pastures are too short, which is caused by returning animals to the paddock too soon, leaving them there too long. And I would also say you can have low dry matter intake problems from grazing pastures which are too over-mature and fibrous and just not very digestible. And these are, of course, leading to things like lower milk production, slower growth rates, poor body condition, and cows that don't breed back. And then if it's the protein problem, you may also see laminitis in hoof problems several months after the high protein feeding time. So I just want to leave on a positive note and say that one of the great things about these management-intensive grazing systems is that making even a really small change in how you manage your pastures can make steady improvement in the pasture quality over time. So just some subtle changes, which might be increasing the number of paddocks, changing the speed that you rotate through the paddocks, and changing so that you have variable recovery periods can really make a huge improvement in pasture quality without having to spend a whole lot of money on seed or soil fertility. So here are some places you can go to get additional information. There's a couple of magazines listed here, the Stockman Grass Farmer and Graze magazine, and then a book by Bill Murphy, Greener Pastures on Your Side of the Fence. It's been around for quite a while, but it still remains one of the most comprehensive, useful books on management-intensive grazing. And then here are a few websites. The e-extension website has the webinars we've been talking about in addition to some of the the videos on how to calculate dry matter intake and some useful articles. ATRA has a whole series of fact sheets on grazing management. Grassfarmer.com will get you to links to tons of websites on grazing management. Sarah Flack Consulting, that's my website, and I do have one article on there that goes through paddock size calculations. That's a fairly simple one to go through. And then the Missouri website, the University of Missouri, has some great dairy grazing resources on there. And I believe that wraps things up. Deb, I don't know if there's more.
Great. Yeah. Hi. Yes. Thank you very much, Sarah and Cindy. So I'm just going to go right in here. The first question that popped up for Cindy is trailing the same thing as soil erosion? Cindy or Sarah?
Well, there you are. I'm sorry, I had it on mute. Okay. Trying to multitask here. Yeah, basically what the trailing does is it actually predicates, it leads to soil erosion because it exposes the soil. So the cattle will trail because they like to follow the path of least resistance back to the water, and that will basically create a soil exposure, and the exposed soil is vulnerable to soil erosion. So that's how the two are linked.
Okay, great. Thank you. So how about mowing and returning green matter back to the soil when you have excess growth with a flush in the spring or in the fall?
Yeah, that's a great question. This is Sarah. And clipping down that material is done in several ways. One is that you may end up grazing some group of animals through the kind of the excess pasture material at the time of the year when it's just growing faster than your animals can keep up with it. You would graze through it, and then you would mow it down right after the animals come out of that area. And there's different methods to mowing it down. It seems like some sort of a brush hog or something that cuts it up finer will help it get returned into the soil a little bit faster. So does hoof impact. So if you're turning the animals in there and they're punching it down into the soil, that'll also help with that. And certainly, I mean, if things are just getting so far ahead of you that you need to just mow it and lay it on the ground, that's an option. It usually is going to be better to bale it up or you know, put it in the silo or something at that point, just so that you don't have too much, you know, dead, dry plant material laying on top of the pasture. I'd also offer another idea that people use, which is pre-clipping, where you actually clip the pasture a lot of times in the morning or the evening before. You leave the material right there in the pasture. It wilts, and then the animals, when they come in, can graze it. And that is defined in the new organic pasture rule as pasture as long as it's clipped and left in the same pasture. And the time that is worth considering is if some of your pastures have gotten over mature or you're growing some plant species that are not as palatable, as a way to increase dry matter intake of that material by the animals. I see that a little less often with dairy and a little bit more often with beef animals when they're really trying to get dry matter intake to the beef animals.
I want to tag onto that. We have actually done that, and it works extremely well. We have issues with curly dock in some areas of our flood irrigated pasture, and the cattle won't touch it when it's lush and green. But if you'd lay it over, like with a swather or just a side mower, and lay it over and allow it to wilt for 6 hours, it changes the chemistry to the point where it becomes sweet, not bitter, and the animals will eat it. And basically you train them to eat your weeds in that way. So it's been, we were trying that on some of the ends of our paddocks where we do have a weed problem, where we would like the cattle to clean that up. And curly dock is actually quite nutritious. If you look at the feed analysis on it, it's not bad feed.
Okay, can you shorten the return time to a paddock in the spring when plants are regrowing at a fast rate? For example, returning cows to a paddock when forage is 6 or 7 inches rather than 8 to 10. What are your thoughts on that?
This is Sarah. It depends on the plant species, and it also depends on which plant species that you want to select for. You'll find that the pre-grazing height that you use most of the time will actually end up causing certain plants to do better in your pastures and other plants to die out. So for example, if you're dealing with cool season perennial grasses and you tend to graze at a 6 to 7 inch pre-grazing height, you will tend to, over time, end up with more white clover and Kentucky bluegrass. Whereas if you go for the higher pre-grazing height, if you go really high, if you go like 10 to 14 inches, you will probably have a pasture that in a lot of the northern climates will switch over to either reed canary grass in the wet areas or to orchard grass in the less wet areas. And so there's no real simple answer to your question. I would say that the one time of the year where you can violate the pre-grazing height rule is the spring, which is what you're asking about, which is where you really don't want to wait until your entire farm is at the ideal pre-grazing height, because if you do that, then you're going to graze one paddock at the correct height, and then the rest of the paddocks are going to be over mature and gone to seed before you get to them. So that's when you can turn in a little bit shorter, but you still are doing a little bit of overgrazing damage there. So the way to deal with that over time is to perhaps consider turning your cows out to different areas for that first spring grazing paddocks each year. So instead of turning them out every spring right next to the barn, maybe run them all the way down the lane and start grazing them at the far end of the pasture system, rotating them back towards the barn instead of away from the barn. That way you won't end up with a whole lot of orchard grass at the far end of your pasture system and a whole lot of Kentucky bluegrass pastures closer to your barn. So it's a complicated answer, but it really is just that the pre-grazing height that you choose is what will largely determine the types of grasses that will grow in your pasture.
Great, thanks, Sarah. So I have a couple of questions regarding alfalfa. So I'm just going to read them both together. One says, I'm wondering about mixing alfalfa and grasses and how to pasture them. And with that question, what grasses will go well with alfalfa? And then the one that's related is, do you have organic strategies for grazing alfalfa and or high legume composition paddocks?
There is at least one variety of alfalfa that is theoretically bred to persist better under grazing management. This is Sarah. My own personal experience with alfalfa is that it tolerates grazing but does not like to be grazed down very short, and so you have to manage it carefully so that it persists. Though I've certainly worked with a few farms over the years that for some reason, soil type, I don't know, they just always have alfalfa in their pastures, and the cows do quite well on it. As far as the species to mix it with, here in the Northeast, generally Timothy or one of the late maturing orchard grass varieties are what folks mix in with it. What I would say about alfalfa is that overall it tends to be less palatable than some of the other legumes, but it's also more drought resistant, so it certainly might be a useful thing to have in your mix. And then I'm assuming you're asking about the risk of bloat with asking about the grazing high legume pastures. And alfalfa, along with the white clover and the red clover, all can cause bloat in cattle. And it is primarily an issue if the legumes have been frosted and the cows are grazing them, particularly if they go out with an empty stomach and they really fill up on frosted legumes. You can have an increased risk of bloat. It's also, you can sometimes get bloat just from a wet or heavily dewed-on legume pasture. The cheapest prevention is feeding a little bit of dry hay or something in the barn. There are some products that are approved for use for treating bloat. Poloxylene is the active ingredient. There's a couple of products with that, and that is on the national list. It's allowed. If you're grazing high legume pastures, you may want to have a few bottles or buy a case of that and keep it in the barn for emergency situations. And Cindy, do you have any experience with grazing alfalfa you want to add in there? Oh, she may have muted herself.
Mm-hmm. I think we'll just move right along because we are running out of time. So this question, this person asked, do gravel lanes increase foot problems? Any experience with that?
Yes. It depends on the gravel. There are distinctly different types of gravel that I've seen used and have used myself for building the lanes. The nicest lanes that I've ever built and worked with dairy cattle on We used a coarser, actually a bank run gravel is what it's called, and this is one of these things where the terminology varies so much from one part of the country to the other that you'll have to figure out what this stuff is called in your part of the country. But here I call it bank run, which is kind of a coarse natural gravel as the underlayers because it's fairly affordable. And then over the top there's kind of a very finely crushed gravel that goes, that is finely enough crushed that it doesn't have a lot of sharp edges to jam into the cow hoofs. And it also packs down and makes a nice uniform, fairly firm layer over the top. And the thing I've had the most trouble with is the coarsely crushed gravel, which I don't think I would use as a top coat on dairies.
Great, thank you. This is a question for Cindy. Cindy, this person asked, I am currently flood irrigating on my ryegrass planted rotational pastures with blended manure water. Any issues with irrigating with blended manure wastewater on your pastures?
Yeah, we're not set up to actually do that, so we have not been using any of our manure water back into our irrigation system. And as far as I know, you basically just need to watch your tailwater and the infiltration rates. We have monitoring wells, and we try to monitor what our groundwater is doing on a regular basis in order that we meet Regional Water Quality Control Board guidelines and regulations. So it would be, I think, worthwhile to at least test your tailwater to kind of see what's coming through there, and if you do have monitoring wells, to go ahead and submit that for a nitrate nitrogen test just to see what's percolating. But you know, besides that, you know, I just don't have a lot of experience working with that manure water, but I think it would be a great resource considering a lot of our paddocks or pastures are low in nitrogen, so it would be a great source of that nutrient and moving those nutrients around and trying to keep them in your system. So I think you just have to use wise application rates, know what's going on your paddock, and also know what's coming off your paddock.
And then this fellow also asks, any need for legumes in the pasture if you are adding that N with the blended manure water?
You know, a lot of that could probably be resolved with the soil analysis and then plant tissue analysis to kind of see where you are with your nitrogen levels. If it appears as though you're really low in nitrogen, then certainly, you know, you're going to have to embellish from other sources: manure water, compost, legumes to fixate nitrogen. You know, those are the three sources that we use in the organic arena. So that's basically how we're monitoring our nitrogen levels, and just to get an idea of where we are and how we need to proceed. We continue to add compost because it's a highly fixed source of nitrogen. All that nitrogen is fixed in the organic matter, and so it demineralizes over time. We know that we don't have losses to volatilization or to leaching when we use compost as a source of nitrogen to enhance the nitrogen level in our paddocks. So that's basically how we've approached it, and I think legumes is another great way to do that. But you do have to make sure that you don't create a situation where you do have 80% composition of clover, because you could run into bloat issues. And Sarah was dead on with her analysis on that. We've got some paddocks that can get to that point where they're 50–60% clover at certain times of the year if we're not careful, and you do have to be very, very careful. Those cattle have to be full when they go out on a paddock like that.
Great. Thank you, Cindy. So where can I find information on optimal regrowth time for different pasture crops?
That's a good question. There isn't a great comprehensive guide on that for the entire country. It's kind of like the question of how long is my grazing season for my part of the country. There also is just not a great comprehensive guide for that. And I would encourage folks to contact their local grazing organization, local NRCS office, local extension or university, attend the grazing workshops and things like that. And I'd say, particularly for those of you in California, what I've found with farms in California is that your growing season, your grazing season, and your regrowth periods are so varied over the farm. Over the state, you can literally drive 2 hours and be in a completely different climate. And so it's very regionally specific. The best source of information really is for you to keep grazing records And after 2 years of keeping grazing records, you'll have a really good idea of exactly how long each paddock needs to regrow, depending on the temperature and the water level. So I don't have a better answer for you than that.
And with that, I'm sorry to say that we are out of time. I'd like to thank you all for your questions. And if I know there were some questions still in the queue here, and I apologize for that. We are out of time. But I encourage you to take a look at that that URL, the www.eextension.org/ask, and you can post your question there, and we will get to you in that way. So as I mentioned before, this webinar is part of an ongoing series regarding the Access to Pasture rule, and we hope to be offering more of these webinars throughout the fall and winter and spring. So you can find more information about these webinars and the recording of today's session, as well as articles, videos, and more at eextension.org/organic_production. Thank you so much for joining us, Cindy and Sarah, and thank you all for coming.